Everyone loves to watch a good fireworks show. But while you're oohing and awing, have you ever stopped and wondered what's behind all those explosions of color?
Well, despite the fact that fireworks are a symbol of celebration, they actually have more in common with our symbols of destruction. That's because fireworks are really just carefully controlled bombs, with a little color thrown in for good measure. Since fireworks shows always take place at night, you rarely get a chance to see where all those colorful explosions come from. So here it is, a typical launch site. And this strange-looking device is a fireworks shell. But how does this produce that? Well, whether you're making bombs, bullets, or fireworks, you need something to make them explode. And with fireworks, the chemical of choice is gunpowder. It's an excellent explosive, and because it's so effective, making fireworks can be a hazardous business. This is the Hans Fireworks Factory in Papineauville, Quebec. Notice that instead of one large building, this factory consists of several small huts. It's done on purpose so that if there's an explosion, only one building gets destroyed instead of the entire factory. Inside the huts, the workers stand on special static-free mats with metal braces attached to their feet. This helps prevent any buildup of static electricity that could spark and set off an explosion. But a fireworks shell is much more than a big bag of gunpowder. If you were to tear away this paper covering, here's what you'd see. Several plastic compartments all glued together, plus this big bag of gunpowder on the bottom. Now, this bag is called the lift charge because its job is to fire the shell up into the air. But that's all gunpowder can really do, explode things. So where do all those beautiful colors come from? Well, the concept is similar to a military grenade. You see, with a grenade, you have a metal casing packed full of explosive. Now, when you pull the pin, the explosive detonates and the casing blows apart. And that's what makes a grenade so deadly. Not the explosive itself, but all the little bits of metal that are sent flying through the air. Yikes. It's the same idea with a fireworks shell. If you were to open up one of the compartments, what you'd find is gunpowder mixed together with these things. They're called stars, and here's what happens. When the gunpowder in the compartment explodes, the stars catch fire and are then sent flying through the air, just like shrapnel from a grenade. And it's these burning stars that are responsible for all those colorful trails of light that we expect from a fireworks show. But how do you control what color the stars will burn? Well, that's just a little basic chemistry at work. You see, when certain chemicals are burned, they emit different colors. For instance, when barium burns, it gives off a green color. When strontium is burned, you get red. Sodium produces yellow. And copper burns blue. Or if you want a big, bright flash of white light, you burn magnesium or aluminum. So back at the factory, the stars are made by mixing together the chemicals of whatever colors you want to see. The size of the stars is also important, because the bigger the star, the longer it burns and the longer the trail it leaves in the sky. So it's the gunpowder that explodes the shells and the stars that provide the color. But we're still missing one component. Timing. You have to make sure the shells explode up there, not down here. And that's the job of the fuse. And you might be surprised to know that each shell can contain several fuses. Let me show you how it all works by walking you through the firing of a typical shell. It's first placed inside a thick tube called a mortar. Now, the fit here is critical. If it's too loose, the explosion will blow around the shell and it won't reach its required height. But if it's too tight, the shell can get jammed inside the mortar and you could get a dangerous ground explosion. With the shell inside the mortar, the main fuse can now be lit. Its job is to ignite the lift charge at the bottom of the shell. The explosion fires the shell into the air, At the same time, it also ignites a slow-burning fuse that's connected to the first compartment. As the shell rises, the fuse continues to burn until it reaches the first compartment full of red stars. But our shell is not done yet, because when the first compartment of stars explodes, it also ignites this delay fuse. Now the fuse burns for a second or two and then detonates the next compartment full of gold stars. But we're still not finished, because when the second compartment exploded, it also lit this fuse, which is connected to the final compartment. Now instead of stars, this compartment is full of powdered magnesium. And when this mixture ignites, you get a loud bang and a large flash of white light. So from this one shell, we get 3 different explosions, all carefully timed by separate fuses. Now, what makes fireworks so spectacular are the variety of explosions that can be produced. And if we take a closer look at the shells, we can see how the manufacturers control the different patterns of light. For instance, if you randomly mix the stars in with the gunpowder, you get a random-looking explosion that looks like this. Or you can place round stars in a circular pattern all around the gunpowder and get a very symmetrical explosion that looks like this. You can also put several small shells inside a big shell to produce a series of rapid explosions. In fact, the number of different shells and patterns that can be produced is limited only by the designer's imagination. Amazing what you can do with a few chemicals and some gunpowder. See, when certain chemicals are burned... Sorry. Well, that's just little basic chemistry at work. You see, certain chemicals